So, if you're holding Bitcoin, you've probably spent a lot of time thinking about security, right? How to protect your keys, keep your assets safe from hackers, all that good stuff. But there's this one huge question that often gets pushed to the side, and honestly, it might be the most important one of all.
Yeah, it's a heavy question, I know, but it's absolutely critical. See, unlike traditional assets that are handled by banks or lawyers, your Bitcoin is 100% your responsibility. So what happens to all that digital wealth if one day you're just not around to access it anymore?
And that's the brutal truth of it. Without a solid plan, your Bitcoin could just vanish, becoming a permanent part of the millions of coins that are already lost to the world. We're not talking about a small problem here. This is a multi-billion-dollar ghost ship of lost value.
So that leads us right into the heart of the matter, what we can call Bitcoin's inheritance problem. The very things that make Bitcoin so powerful, the decentralization, the lack of middlemen. Well, those are the same things that make it super vulnerable to being lost forever if you haven't planned ahead.
But here's the good news, and it's really good news. The same exact technology that gives you total control over your money also gives us the tools for an incredibly elegant solution, one that doesn't involve lawyers, courts, or trusting some third-party custodian. We're talking about a truly self-sovereign solution.
So, what does a perfect inheritance plan even look like in the Bitcoin world? Well, it really has to nail 3 key things. First, it's got to be automatic. It just kicks in without anyone needing to do anything. Second, it has to be completely private, no ID checks, no questions asked. And maybe most important of all, it has to be self-sovereign. You're not trusting anyone, period.
Okay, so how in the world do we actually pull this off? It sounds pretty futuristic, I get it, but it all boils down to 2 really powerful tools that are baked right into Bitcoin's code. Let's break down the tech that makes all of this possible.
First up, we have the multisig wallet. Just think of it like a digital vault that needs more than one key to open it. This is so crucial because it means there's no single point of failure. While you're around, it protects your Bitcoin from being stolen or from you accidentally losing a key.
The second piece of this puzzle is something called time locks. And this feature is it's genius. A time lock is basically a digital time capsule that's sealed and enforced by the entire Bitcoin network. You set a timer, and after that specific amount of time has passed, the rules for how you can access the money automatically change.
Now, there are a couple of ways you can set this up. The on-chain model is the purest form. It's enforced directly by the Bitcoin network itself, which means it gives you the absolute maximum self-sovereignty. It's designed to work even if the company that helped you set it up disappears. The off-chain model is a bit more flexible, but it does mean you're placing a little bit of reliance on a company like Nunchuck. For that truly trustless, bulletproof setup, on-chain is really the gold standard.
All right, so we've got the building blocks, multisig and time locks. But how do they actually come together to create a real working inheritance plan? Well, it helps to think of it as a process with 2 very different phases.
Phase 1 is the before picture. This is while you're alive, you're well, and that time lock countdown is still ticking away. During this whole period, the entire system is set up for your security and your control.
So, in this phase, you need multiple keys to spend your money, just like that digital vault we talked about. You're in charge. You can even set up things like daily spending limits, using a cosigner to approve small, everyday transactions, so you're not juggling multiple hardware wallets just to buy a coffee. The main takeaway here is, you are in complete and total control.
And that brings us to phase 2. This is the moment that digital time capsule unlocks. Once that timer you set, let's say it's for 1 year, once it expires, the fundamental rules of the wallet just change automatically.
And this is where the plan's genius really shines. After that time lock expires, everything simplifies. Your heir only needs one key, their specific inheritance key, to access and spend the funds. The other keys, including that cosigner key, become useless for spending. All the control just seamlessly and automatically transfers right to your designated heir. No fuss, no muss.
So, we've walked through how the plan works from your perspective. But what about the person on the other end, the person actually receiving the inheritance? Well, the beauty of this whole system is just how simple it is for them. Let's take a look.
Your heir does not need to be a Bitcoin wizard. Not at all. All they need is what you could call an inheritance kit. This kit is super simple. It's got a magic phrase, so they can easily identify the plan, the inheritance key itself, which could be a hardware wallet or just a seed phrase written down, and you could even have a trusted third party, like a family friend, hold on to this info for them.
And here's the part that is just so revolutionary if you're used to the old way of doing things. There are no lawyers to call, no death certificates to present, no accounts to open, no identity checks. The entire process is private, it's permissionless. If your heir has the key, they have the Bitcoin. It really is that simple.
Of course, setting this all up right is a big deal. The source material gives some fantastic practical advice. For example, store your seed phrases on steel plates, not paper, so they survive a fire or a flood. Keep things simple. Don't use a super complex passphrase that's just going to confuse your heir. And here's a big one. Test the whole thing out first. Use a tiny amount of Bitcoin and a short time lock, like a week, just to make sure everything works exactly the way you think it does.
When you zoom out, it all comes down to this powerful idea. This technology gives us a way to handle inheritance that is truly native to Bitcoin. It's automatic, it's private, and it's completely self-sovereign. It takes on the single biggest risk of holding Bitcoin for the long haul, that risk of it being lost forever, and it solves it.
So look, the tools are out there. Your wealth, your rules, your legacy. It can all be secured in code, ready to be passed on to the next generation without having to trust anybody. The only question left for you to ask yourself is yours set up?
Welcome to the debate. So today we're confronting what might be, well, perhaps the single greatest existential threat to cryptocurrency wealth. And it isn't hacking, it isn't regulation, and it certainly isn't a market crash. It is simply the death of the owner. We are analyzing a highly technical and I'd say somewhat philosophical document titled Legacy in Code, the Sovereign Bitcoin Inheritance Guide. It really tackles a problem that's unique to bearer assets. I mean, if you have money in a bank and you die, a court order moves the funds. It's bureaucratic, sure, but the money doesn't just vanish. If you have Bitcoin secured properly, truly self-sovereign, and you die without a plan, those funds are mathematically inaccessible forever. They're effectively burned.
It is the ultimate buzz factor, yeah. And this guide proposes a solution that is, well, it's pretty radical even for the crypto space. It outlines a method using the nunchuck wallet infrastructure to pass on wealth without lawyers, without probate courts, and this is key, without identity checks. It's proposing an inheritance plan that's enforced entirely by cryptography.
Which brings us to our central question. Is this self-sovereign inheritance, specifically the on-chain model described in the text, is that the gold standard for securing a legacy? Or is it a rigid, unforgiving trap that demands far too much technical competence from, grieving families?
It really comes down to a choice between two risks, doesn't it? The risk of third-party failure or the risk of user error. And honestly, looking at the complexity here, user error feels like the monster in the closet.
Well, I'm taking the position that the on-chain model described in the source is the superior approach. I mean, the guide makes a really compelling case that true security requires removing human institutions from the critical path. The on-chain time lock ensures that inheritance is automatic and censorship-resistant. It works even if the service provider, Nunchuck, completely disappears. That, to me, is the definition of a legacy that lasts.
And I am taking the position that while the on-chain model is technically impressive, I mean, it's a feat of engineering, really, the off-chain or hybrid approaches that are also acknowledged in the text are far more practical for the real world. The guide explicitly notes that the on-chain model is harder to change, and I argue that this rigidity, combined with the burden of managing magic phrases and hardware, it just sets heirs up for failure. We are talking about grieving spouses, not systems administrators.
Okay, so let's look at the core problem that the source material identifies. It says, Bitcoin is easy to lose if no one knows how to access it. The guide is clearly responding to a landscape where millions of coins have just been lost because owners trusted their memory or failed to trust anyone else. The solution it proposes is a multisig wallet. For our listeners, this just means the funds are not controlled by a single key, but by a sort of quorum of keys.
Right. The classic 2 of 3, or, a similar setup.
Exactly. The text details a specific configuration involving the owner, the heir, and the nunchuck service. But the on-chain aspect is the critical differentiator. In this model, the rules of inheritance, specifically a time lock, are inscribed directly onto the Bitcoin blockchain, This means the scripts that allow your heir to claim the funds is enforced by the Bitcoin network's miners, not by some database at Nunchuck headquarters.
Which sounds incredibly robust until you realize what enforced by miners actually imply.
It implies certainty. I mean, the guide emphasizes that this model avoids lawyers, custodians, or KYC requirements. It creates a direct peer-to-peer transfer of generational wealth. If we accept the premise of Bitcoin as sovereign money, then this is the only logical conclusion for inheritance. Anything else just reintroduces the counterparty risk that Bitcoin was designed to eliminate. If you bring the lawyer back in, you've brought back a point of failure.
See, I don't dispute the elegance of the cryptography. I really don't. But I do dispute its application to, human tragedy. The source explicitly provides a comparison table between the on-chain and off-chain time locks. And under the on-chain column, the text lists a pretty significant trade-off: harder to change. We really need to unpack what that means.
It means it's immutable.
It means it's stuck. If you set up an on-chain inheritance plan, you're creating an irrevocable transaction path. But life is volatile. You might get a divorce. You might have a falling out with your heir. You might lose one of your own keys. In the on-chain model, fixing these problems requires a really complex technical operation to move funds to a whole new setup. You basically have to tear down the house and build a new one just because you lost the front door key.
That is the price of security.
But is it? In contrast, the off-chain model, which is managed with Nunchuck's assistance, is described as more flexible. It allows for policy updates without necessarily moving funds on-chain. By insisting on this on-chain purity, you're forcing users to predict the future. And the guide also details what the heir needs: a magic phrase, an inheritance key, and potentially a hardware device. This isn't just an inheritance, it's a technical exam administered during a funeral.
I want to challenge your definition of rigidity. You view it as a flaw, the text presents it as the ultimate security feature. Let's look at the mechanism of the time lock itself, because I think it solves the flexibility issue better than you suggest. The source details that while the owner is alive, the wallet functions as a standard multisig. Spending requires multiple signatures, specifically the owner's key plus Nunchuck's key, or the owner's two keys. Nunchuck can co-sign small transactions for daily utility. It's not, frozen.
Sure, while you're alive, it's fine. I get that.
But here's the breakthrough. The script includes a condition that says, if X amount of time has passed since the last activity, the signing requirements change. After that time lock expires, the text states, only one key is needed.
Only one key is needed? Yeah. That's the phrase that worries me.
Why? It's a graceful degradation of security. It goes from a fortress that requires collaboration to a simple door the heir can open alone. It assumes that if the owner hasn't touched the funds in, say, a year, they are likely gone, and the security model should shift to accessibility.
Because it creates a security cliff. You are relying on a dead man's switch. What if the owner goes into a coma, or is just inactive for the duration of the time lock? Let's say it's a year. The security of that entire wallet drops from multi-sig to single sig.
Well, that's why you set the time lock appropriately.
But look at the risk profile. The guide says Nunchuck's key becomes invalid after the lock expires. That means if a bad actor has somehow managed to steal the heir's key or the inheritance key, they just have to wait out the clock. In the off-chain model, Nunchuck could presumably still act as a gatekeeper or a second factor to stop a thief. In the on-chain model, the code just says, time is up. Whoever has the key gets the money. Code lacks context. It can't distinguish between a legitimate heir and a patient thief.
I think that's a fundamental misunderstanding of the threat model. The on-chain model is designed to protect against censorship, not just simple theft. If Nunchuck retains the power to stop a thief, they also retain the power to stop the heir.
That is a fair point, theoretically.
No, it's not just theory. The source explicitly mentions that the on-chain model works even if Nunchuck disappears or is regulated out of business. If you use the off-chain model, you are betting your children's inheritance on the fact that Nunchuck as a company will outlive you. That is a massive gamble. We have seen exchanges, wallet providers, custodians just vanish overnight. The Bitcoin protocol will survive Nunchuck, The on-chain model anchors your legacy to the blockchain, not a startup's funding runway.
That is a valid systemic risk, I'll grant you that. But let's look at the user risk. The section What Heirs Actually Need is very revealing. It lists a magic phrase and the inheritance key. Now, look at the practical security guidance that's provided. The author advises, store seed phrases on steel, not digitally. So the plan requires you to hand your non-technical spouse or child a heavy steel plate and a magic phrase, and eventually they have to interface with a hardware wallet.
It's physical possession. It's akin to handing someone a gold bar, but it's easier to transport and much harder to confiscate.
It is not like a gold bar. A gold bar doesn't require firmware updates. A gold bar doesn't require you to understand how to input 24 words into a device without exposing them to the internet. And you should note the contradiction in the text regarding security complexity. The guide advises avoid passphrases to reduce complexity.
And how is that a contradiction?
Well, for our more technical listeners, a passphrase is an extra word added to the seed phrase for encryption. It's a salt. It's a standard security practice to protect against the physical theft of the seed. The fact that the guide explicitly advises against using passphrases for these inheritance wallets is basically an admission that the system is too brittle for average users. They are forced to lower the encryption standard because they know the heir will likely forget the password.
I interpret that very differently. Avoid passphrases is a recognition that human memory is the single biggest point of failure. The guide is shifting security from something you know to something you have. If the heir possesses the hardware device, the inheritance key, and the written backup, the steel plate, they have access. No memory is required. This eliminates the risk of a forgotten password wiping out the entire inheritance. It simplifies the heir's job to pure physical custody.
But physical custody is so fragile. Fires happen, thefts happen, floods happen. If I lose that steel plate and I don't have a passphrase in my head as a backup, the money is just gone.
Which is why the source suggests an optional trustee to hold information.
Optional. And again, we're back to trusting humans.
Yes, but strategic humans. The trustee holds information, not the funds. They might hold the magic phrase or just a location of the backup. This bridges that gap. It introduces a human element to aid recovery without giving that human the power to spend the coins. They're a compass, not a captain.
But even with the trustee, you're still relying on social coordination. I mean, if the trustee hates the heir, or if the trustee just loses the info, the system stalls. And let's be honest, asking a friend to be a trustee for a cryptographic key setup is a huge ask. Hey, can you hold on to this steel plate for 30 years and please not lose it?
It beats paying a bank 1% a year for 30 years to do the same thing, and probably less securely.
Maybe. But let's look at the security during the transition again. I want to circle back to the role of Nunchuck. In the on-chain model, once the time lock expires, Nunchuck's key becomes invalid.
Correct. This prevents the company from holding your funds hostage. It's the kill switch for the middleman.
It also prevents the company from offering technical support at the protocol level. Imagine the heir is trying to broadcast the transaction. The fee market spikes. The transaction gets stuck in the mempool. They don't understand replaced by fee. They call Nunchuck. In the on-chain model, Nunchuck has to say, sorry, our key is mathematically invalid. We literally cannot help you push this transaction through. The heir is completely alone in the dark forest of the blockchain. In the off-chain model, Nunchuck stays in the loop and can assist.
You're prioritizing customer service over sovereignty. The entire ethos of this document is sovereign Bitcoin inheritance. If you need to call customer service to access your money, it's not your money. It's an IOU.
That sounds heroic, but in practice, it might just mean lost money.
And this is why the section on testing and implementation is so vital. The author of this system doesn't suggest you just set it and forget it.
See, the testing section is exactly what convinces me this is too dangerous for most people.
How so? It's the most responsible part of the entire guide.
The guide advises test the setup with a short time lock before committing real funds. Just think about what that implies. It implies that the setup is so complex and prone to configuration error that you have to perform a dry run to ensure you haven't accidentally burned your own money. You have to simulate your own death, wait for the mock time lock to expire, and have your heir practice sweeping the funds.
That is standard engineering due diligence. You don't drive a truck over a bridge without testing its load capacity. The dry run is a feature. It forces the family to rehearse the trauma, yes, but in a controlled environment. It turns an abstract, scary event into a procedural memory. By setting a 24-hour time lock and practicing the transfer, the heir gains confidence. They aren't learning the system while grieving. They are executing a plan they have already mastered.
It is a heavy burden. You are asking people to role-play their own demise. Okay, honey, pretend I'm dead, now go get the steel plate. And what if you make a mistake in the configuration? Let's say you mess up the script and set a 10-year lock instead of a 1-year lock because you fat-fingered a digit. That mistake is immutable on the blockchain. The off-chain model, being more flexible, likely allows you to correct those errors because the logic isn't baked into the Bitcoin ledger until the transaction is actually signed.
But the off-chain model leaves a data trail. We haven't even touched on privacy. The source notes, no identity checks. If you use the off-chain model, you're likely relying on Nunchuck's internal database to track the inheritance logic. That's data that can be subpoenaed, hacked, or leaked. The on-chain model is private. The blockchain just sees a script, not a name. For many Bitcoin holders, privacy is the prerequisite for security.
Privacy is valuable? Yes. But is it worth the risk of technical lockout? The source frames the core problem as losing Bitcoin because no one knows how to access it. My entire argument is that by using the on-chain model, you might be increasing the risk that no one knows how to access it. You're just replacing the bureaucratic friction of a bank with the technical friction of cryptography. A bank manager can override a lost password. The Bitcoin network cannot.
And that lack of an override is the whole point. If a manager can override it for you, they can override it against you. The legacy in Code Guide is for those who understand that in the long timeline of history, institutions always fail. The source makes a profound point. The on-chain time lock works even if Nunchuck disappears. If you are building a legacy for 20, 30, 40 years from now, betting on the survival of a specific tech startup is just poor risk management. Betting on the survival of Bitcoin block production is the safest bet in finance.
That is a philosophical stance, and it's a strong one. But practically, most wealth is lost within 3 generations not because of institutional collapse, but because of family mismanagement. The off-chain model acts as a guardrail. It allows for the messiness of human life. If the heir loses the device, Nunchuck is there. If the owner changes their mind, the policy is updated instantly. The guide itself admits the off-chain model is more flexible. In the context of inheritance, flexibility is survival.
And flexibility is also an attack surface.
It's a trade-off. It's always a trade-off.
All right. We should probably try to synthesize this. We've dissected the legacy and code guide. I maintain that the on-chain time lock is the superior solution described. It aligns with the fundamental reality of Bitcoin. It is trust minimized. It converts the subjective wish of the owner into objective, unstoppable code. It fulfills that promise of being automatic, private, and self-sovereign. The complexity, the testing, the steel plates is the necessary price for absolute certainty that your legacy relies on nothing but the blockchain itself.
And I maintain that for the vast majority of people, including many dedicated Bitcoiners, the off-chain or a hybrid model is the wiser path. The source's own admission that the on-chain model is harder to change is a massive warning sign. Life is fluid. Death is unexpected. Locking your wealth into a rigid cryptographic script creates a fragility that the flexibility of the off-chain model resolves. That reliance on Nunchuck as a cosigner is a feature, a safety net for heirs who are not technical experts.
There is, however, some common ground in the source material that applies regardless of which model you choose.
Absolutely. The practical security guidance is universal.
First, store your seed phrases on steel. Paper degrades, ink fades, steel endures.
Second, complexity is the enemy. The advice to avoid passphrases for inheritance wallets is sound. Do not rely on your heir remembering a password. Possession of the physical keys must be enough.
And finally, and perhaps most critically, test the setup.
On that, we are in total agreement. A theoretical inheritance plan is a hallucination. Until you have simulated the death event and successfully recovered the funds in a test environment, you do not have a plan. You have a wish.
So this debate really forces us to ask where we place our ultimate trust. Do we trust the cold, unyielding logic of code to carry our legacy across that final threshold?
Or do we trust the adaptable, guided support of human systems to navigate the chaos of loss?
There is much more in the guide regarding the specific opcodes and script types, but we will leave the technical deep dive there.
It has been a pleasure debating the void with you.
Thank you for joining us on The Debate.
Imagine it's a Tuesday, just a regular, mundane Tuesday.
Yep.
The sun is shining, maybe you're walking to get a coffee, feeling that morning breeze.
Mm-hmm.
You pull out your phone, check the charts. It's just a habit, right? And you see a little green candle. You feel good.
That little dopamine hit.
Exactly. You feel smart. You've spent the last 5, maybe 10 years going down the rabbit hole. You've stacked sats. You've done the responsible thing.
The sovereign thing.
You've moved your coins off the exchanges because not your keys, not your coins.
The mantra.
You've got the hardware wallets, maybe a cold card, maybe a ledger tucked away in a safe. You've stamped those seed phrases into titanium plates that are like rated to survive a house fire or a nuclear blast.
You've done everything right.
You are effectively a financial fortress. You are your own bank.
That is the dream.
Okay.
Is the pinnacle of the ethos we talk about all the time. Unseizable, censorship-resistant, sovereign money.
Right.
You have achieved total independence from the system.
Exactly. You are the CEO, the vault manager, and the security guard of your own wealth. But then,
Here it comes.
screech, the bus. The literal or, the metaphorical bus.
Right.
Maybe it's a car accident. Maybe it's a sudden medical event. Maybe it's just the slow, inevitable march of time that none of us can outrun. But suddenly, you are gone, lights out.
And that fortress.
And that fortress you built, that impenetrable vault that keeps the hackers and the government and the scammers out, it does its job too well. It keeps everyone out, including your spouse, including your kids.
It turns into a tomb. That is the dark side of sovereignty.
Yeah.
A cryptographically sealed tomb where the wealth exists, you can see it on the blockchain, but it's utterly untouchable.
That is the nightmare scenario we're grappling with today, the bus factor. We spend thousands of hours listening to podcasts, reading technical manuals, and obsessing over how to secure our Bitcoin from theft. We build higher and higher walls.
In higher, yeah.
But we often forget that we need to build a door for the people we leave behind. And when you are the bank, there is no forgot password link.
No.
There is no friendly branch manager to call who can override the system because they saw your obituary in the paper.
That's the double-edged sword of self-custody. The Bitcoin protocol is neutral. It doesn't care about your intent.
It's just math.
It's just math. It doesn't care that you loved your family and you wanted them to have this wealth to pay off the mortgage or go to college. It only cares about the keys.
Just the keys.
If the keys aren't there or if the signatures aren't valid, the math says no. And that wealth is effectively donated to the rest of the network by disappearing from the supply forever.
Which is a terrifying thought. I've seen estimates suggesting that billions, with a B, billions of dollars in Bitcoin, are already lost.
Oh, easily.
Just gone, permanently inaccessible because early adopters died without passing on the knowledge. It's a tragedy.
It's a digital graveyard.
But look, we aren't just here to scare you. We aren't here to wallow in the fear of mortality. We are here to fix this.
We are. And the solution we're looking at today is fascinating because it doesn't involve trusting a lawyer.
No.
And it doesn't involve trusting a bank.
Right. We are doing a deep dive into a very specific, very technical, and frankly, very cool set of documents. We're looking at excerpts from a guide titled Legacy in Code, the Sovereign Bitcoin Inheritance Guide. And the premise here is radical. It's about building an inheritance plan that runs on code, not on legal paper.
This guide is effectively the manual for the sovereign individual who wants their legacy to be as unstoppable as their money.
Right.
It focuses on using the Nunchuk wallet infrastructure to create a plan that is automated, private, and trust minimized. It's about taking the principles of Bitcoin Don't Trust, verify, and applying them to the afterlife.
So our mission for this deep dive is to unpack this guide. We're going to look at how you can set up what is essentially a dead man switch for your life saving.
Yeah, that's a great way to put it.
We're going to talk about multisig, time locks, And why putting your seed phrase in a safety deposit box at the local bank might actually be the worst thing you can do.
It's going to get a little technical at points, but we're going to break it down because the payoff is huge.
What's the payoff?
Peace of mind that doesn't rely on anyone else's permission.
Let's start with the status quo, the default setting for most people. Because I think most people, if they think about this at all, they think, okay, I have a will.
Right. Standard procedure.
My lawyer has a copy. I'll just write down my 12 words on a piece of paper, put it in a sealed envelope, and tell my lawyer to give it to my wife if I die.
The envelope method.
Or maybe they put it in a safety deposit box. Why does legacy and code say this is such a bad idea? Why is the traditional route so flawed for Bitcoin?
Well, it contradicts the very reason you bought Bitcoin in the first place.
How so?
Think about it. You bought Bitcoin to avoid counterparty risk.
Right.
You didn't want to trust a bank to hold your money. You didn't want to trust the Federal Reserve. But if you hand the literal keys to the kingdom, your seed phrase, to a lawyer, you've just introduced a massive third-party risk.
You're trusting the lawyer.
You're trusting the lawyer.
And not just the lawyer, but their security, their whole office.
Exactly. You're trusting the lawyer's honesty, sure, but you're also trusting their operational security. OPSEC.
Okay.
You're trusting that their paralegal doesn't get curious and open the envelope. You're trusting that the cleaning crew doesn't snoop around at night.
Right. Anyone.
You're trusting that their office doesn't get broken into. If anyone, literally anyone, sees those words, the money is gone.
Instantly.
Instantly. There is no reversible transaction in Bitcoin. If a thief steals your gold bars, you might catch them and get the gold back.
Maybe.
Maybe. But if a thief sees your seed phrase, they can sweep the wallet in 10 seconds on the other side of the world.
That's a chilling reality. A piece of paper in a file cabinet is not security.
Not for a bearer asset of this magnitude.
And there's the issue of privacy too, right? Probate isn't exactly a secret process.
No, it's not. Not at all. In many jurisdictions, once a will goes to probate, it becomes a matter of public record.
So anyone can just look it up.
Anyone can go to the courthouse and pull the file. If your will says, I leave 10 Bitcoin to my son, located at this address, or even if it just reveals the magnitude of the asset.
Oh, wow.
You have just put a massive target on your heir's back. You've announced to the world and to scammers, criminals, and extortionists that this specific person has a bearer asset worth a fortune.
You're basically doxing your family at their most vulnerable moment.
Precisely. And then there's the permission aspect. The source material talks a lot about KYC, know your customer.
Right.
We're used to this with banks, but in inheritance, it's a huge friction point.
Right. If I die and leave a bank account, my wife has to go to the bank with the death certificate, the will, her ID, a whole stack of papers.
And she has to ask, please, may I have my inheritance? She is asking for permission.
She has to prove who she is, prove I'm gone.
And the custodian, the bank, or even a specialized crypto inheritance firm can say no. They can say, we need more documents.
Or the government can step in.
Or the government can step in and say, freeze this pending an investigation. Or, and this is the big one in crypto, the custodian could be bankrupt.
Ooh, yeah.
Look at FTX. Look at BlockFi. Imagine you left your Bitcoin on a custodial platform for your kids, thinking it was safe, and the company implodes 5 years before you die.
Or 5 days after.
Or 5 days after. If your inheritance plan relies on a company existing in 30 years and agreeing to release funds, that is not sovereign.
Not at all.
That is just traditional finance with extra steps.
That's a really strong point. You're just trading one master for another.
Yep.
So the guide argues that we need a system where the permission comes from the math, not from a human being.
Correct. The blockchain doesn't do KYC.
Right.
It doesn't ask for a death certificate. It doesn't care if you are a good citizen or a bad citizen. It just checks the digital signature.
That's all that matters.
That's it. If the signature is valid, the transaction processes. The goal of this guide is to construct a valid transaction that can only be created after you are gone without needing a human to approve it.
Okay.
It's about automating the transfer of title through cryptography.
That sounds like magic, but I know it's just very clever engineering. So let's get into the building blocks. How do we actually build this?
Right.
The guide relies heavily on two main technical concepts. The first one is multisig. We hear this term thrown around in Bitcoin circles constantly. Use multisig, it's safer.
All the time.
But for the person who just has a ledger in a drawer, let's break this down completely. What is the actual mechanic here?
Okay, so most people use single signature.
Got it.
That's your standard wallet.
Yeah.
You have one private key. those 12 or 24 words, that one key is like the one ring in Lord of the Rings.
Okay, good analogy.
It has total power. If you have it, you can move the funds. If you lose it, the funds are gone. If someone steals it, the funds are stolen.
It is a single point of failure.
A massive one. It's extremely fragile. It relies on you being perfect 100% of the time.
Which nobody is.
Precisely. Multisig, or multisignature, changes the rules. Instead of one key, the wallet is built from multiple keys. A common setup is 2 of 3.
Meaning there are 3 keys in existence, but you need any 2 of them to move the money.
Exactly. Imagine a bank vault door that has 3 different keyholes.
Okay.
You need to turn 2 keys simultaneously to open the door. You could have 1 key, your spouse could have 1 key, and a lawyer could have 1 key. Or, more likely in a sovereign setup, you hold 2 and a trusted service holds 1. Or you hold all 3 in different places.
So if I have 1 key on a hardware device in my home safe and a hacker manages to break in and steal it,
They can't do anything.
nothing.
Nothing. They have 1 key, the math requires 2. They can stare at the balance, they can see the millions of dollars, but they can't move a single Satoshi.
Wow.
It renders the physical theft of a single device useless.
That creates a massive safety buffer. It's a game changer for security.
It distributes the trust and the risk. You can keep 1 key at home, 1 key in a safety deposit box at a bank, and maybe a 3rd key with a trusted family member or a service provider like Nunchuck. No single location compromises the whole stash.
And this protects you from what they call the $5 wrench attack.
It helps, yeah. Where someone threatens you for your key, because even if they get the key at your house, it's not enough. They'd have to know about the other keys and where to find them.
Okay, so multisig is the foundation because it prevents the evil maid attack someone, finding your backup and wiping you out.
Right.
But multisig alone doesn't solve the inheritance problem, does it?
Right.
If I have a 2 of 3 setup and I die and my keys are scattered, my wife still needs to know how to find them, retrieve them, and use them.
Right. And that is the paradox. Multisig secures the funds, but it makes access harder. It increases the complexity. Complexity is the enemy of execution, especially in a crisis.
Especially for someone who's not a Bitcoiner.
Exactly. If you require your grieving spouse to travel to 3 different locations, retrieve 3 different devices, and combine them using software they've never seen, that's a recipe for failure.
Yeah, that's not going to happen.
They might find 1 key but not the other. They might find the keys but not know the PIN codes. It's too much.
Enter the second concept, the time lock. This is the part of the guide that felt the most sci-fi to me. It's like a plot device in a spy movie.
It really is, but it's a native part of Bitcoin's scripting language. It's been there for years, specifically something called CLTV or Check Lock Time Verify.
Okay.
But tools like Nunchuck are finally making it accessible to normal people through a nice interface.
So what is a time lock in this context? What does it actually do?
A time lock is a condition placed on a transaction or a spending path. It effectively says, this specific key or this specific way of moving the money is invalid until a certain amount of time has passed.
So I can write a rule that says, this inheritance key cannot spend the coins until block height X, or until 365 days have passed.
Exactly. You're programming the money to have different rules at different times.
Okay, so it's a decaying security model.
Or a dead man's switch, yeah.
Yeah.
You are programming the money to behave differently, depending on when someone tries to spend it.
How does that solve the I'm alive versus I'm dead problem? That seems to be the core issue.
Well, the biggest fear with giving your heirs keys now while you are alive is that they might mess up.
Oh, yeah.
They might get hacked, or let's be cynical for a moment, they might decide they want their inheritance early.
The greedy nephew scenario.
A greedy nephew scenario, exactly. Or even just a mistake. They lose the key you gave them.
Right, right.
You want to retain control while you are capable. So you set up a time lock. You give the heir a key, or put it in a place they can access. But that key is mathematically useless right now.
Useless.
Completely. If they try to broadcast a transaction with it today, the Bitcoin network rejects it. It's a dud key until the timer runs out.
And if I'm alive, I keep resetting the timer somehow.
In a sense. We'll get into the specific alive workflow in a minute, but basically, your normal activity with your primary keys keeps the funds moving or refreshed, effectively pushing that inheritance window into the future.
So my activity keeps the clock from running down.
Yes. But if you stop, if you disappear,
The clock ticks down.
silence allows the timer to expire. And once it hits 0, that dud key suddenly becomes live. The smart contract of the wallet changes its own rules.
That is, it's elegant. It's really elegant. It uses time itself as the trigger.
It removes the need for a third party to verify death.
Right, no death certificate.
The verification is simply, the owner hasn't acted for X days, therefore we assume the heir should have control. It substitutes inactivity for death certificate.
Now, the guide makes a very crucial distinction here, and I want to spend some time on this because it gets to the heart of sovereignty. It talks about on-chain versus off-chain inheritance.
This is the most critical technical decision you make when setting this up. And frankly, it's where a lot of commercial solutions fail the sovereignty test.
Okay, so break it down. What is an off-chain time lock? What does that even mean?
An off-chain time lock is basically a promise made by a server. In this case, let's say Nunchuck's server.
A promise.
A promise. You tell the Nunchuck app, hey, if I don't log in for 365 days, please send an email to my wife with the backup key, or please allow her account to access the wallet.
Okay. That sounds convenient. It's like a scheduled email.
It is very convenient. It's flexible.
Yeah.
You can change the recipient, change the time duration, update the message all instantly because it's just a database entry on Nunchuck's computer.
Just software.
It's SQL code, not Bitcoin code.
But I sense a massive but coming.
The but is platform risk. You are trusting Nunchuck, the company, to exist.
Yeah.
If Nunchuck goes out of business,
The email never gets sent.
the server goes offline. If the government seizes their servers, the email never gets sent. If they get hacked, the data might be corrupted.
You're back to counterparty risk.
You are relying on a company to execute your will. That is not sovereign. That is just a tech-heavy version of a lawyer.
It's centralized. You've reintroduced the middleman you tried to escape.
Exactly. Now contrast that with on-chain.
This is what the guide advocates for. This is the goal.
Yes. On-chain means the time lock is written into the Bitcoin transaction script itself.
Into the actual Bitcoin transaction.
Yes. It is baked into the UTXO, the unspent transaction output. That rule is propagated to tens of thousands of Bitcoin nodes around the world.
So every node.
Every node running Bitcoin Core knows about your time lock.
So the rule is on the blockchain ledger itself.
Yes. It is indelible. It's immutable.
Yeah.
Even if Nunchuck, the company, files for bankruptcy, dissolves, and their office turns into a Starbucks,
Right.
the Bitcoin network still knows the rule. The Bitcoin network will still say, okay, 365 days have passed since this output was created. The secondary spending path is now valid.
That is robust. That is true. Set it and forget it.
It's the closest thing we have to immortality in finance. The code executes regardless of human institutions.
Oh.
You aren't relying on a server being plugged in. You're relying on the Bitcoin network continuing to produce blocks.
But there has to be a trade-off, right? The guide mentions flexibility issues with the on-chain model.
Yes, there is. Writing to the blockchain is permanent, like pouring concrete.
Okay.
Once you set up an on-chain plan, you can't just log in and say, actually make it 6 months instead of a year. You can't just edit the rule.
So how do you change it?
To change the rule, you have to move the money. You have to spend the Bitcoin from the old wallet to a new wallet with the new rules.
Which incurs transaction fees.
Fees and effort. It requires an on-chain transaction. But the guide argues, and I agree, that for your life savings, for your generational legacy, you want concrete.
You want permanence.
You don't want drywall.
Yeah.
You want something that is hard to change because that means it's hard to break.
So Legacy in Code strongly advocates for the on-chain model.
It does. If you are going to go through the trouble of self-custody, why stop at the finish line?
Go all the way.
Go the full distance and remove the counterparty risk. Don't build a fortress and give the spare key to a startup.
Okay, I'm sold on the concept. Let's walk through the actual life cycle of this wallet.
Let's do it.
I want the listener to visualize what this looks like day to day, because one of the barriers to this stuff is thinking it's too complicated to use.
Right, the UX fear.
People think they'll need to act like a hacker every time they want to buy a coffee.
Right. So let's look at scenario A. You are alive. You have set up this Nunchuck wallet with an inheritance plan.
Okay. I'm alive, I'm kicking, I want to buy a car or just restack some sats. How does this multisig setup work for me? Do I need to dig up 3 steel plates every time I want to move funds?
No. And that's where the software, specifically Nunchuck in this guide, handles the UX. Remember we said it's the multisig? Let's say it's effectively a 2 of 4 setup where keys are distributed between you, Nunchuck, and your heir.
Okay, 2 of 4. A little more complex.
A little. But while you are alive, you hold 1 key, maybe on your phone, a hot fee or a hardware wallet that sits on your desk.
So 1 key is convenient.
Very convenient. And Nunchuck holds a 2nd key on their server.
So they are a cosigner.
Yes. So for daily transactions, You sign with your key, Nunchuck server checks your request, and if it meets your rules, they sign with their key. Boom, 2 signatures.
Transaction valid.
Transaction valid. It's super fast. It feels like a standard mobile wallet.
To it's seamless.
You scan a QR code, you click sign, it works. But there is a safety mechanism here. To protect yourself from Nunchuck or a hacker on your phone draining the wallet, the guide mentions setting daily limits.
Like a debit card limit? My bank does that.
Exactly. You can code a rule that says, with this specific combination of keys, my phone plus Nunchuck, I can only spend 0.1 BTC per day.
So if a hacker compromises my phone and tricks Nunchuck's server,
Or if Nunchuck is evil or compelled.
they can only get a sliver of the stack.
Right. They get the daily limit, not the vault. It minimizes the blast radius of a hot wallet hack.
So let's say I do want to move the whole stack. Maybe I'm buying a house or fleeing the country.
An emergency, yeah.
I can still do it, right?
You can.
Yeah.
But you would need to go dig up your cold key, the one in the safe that isn't connected to the internet.
The third key?
Your third key, yes. That key has higher privileges. If you sign with the cold key plus your phone key, you can override the limit.
I see. So there are different spending paths with different rules.
Exactly. That balances security and convenience really well. I can buy coffee, well, expensive coffee, or move small amounts without a ceremony, but the bulk is safe.
That's brilliant. Okay, so that's my day-to-day.
Correct. Now let's look at the inheritance key, the fourth key in our 2 of 4, the one for your son or daughter. Where is that?
It's sitting in a safe, or maybe with a trustee somewhere safe.
Right. But right now, while you are alive, it is dormant.
Because of the time lock.
The script on the blockchain says this key has 0 power. If your son finds it and tries to use it, the network laughs at him.
Okay. Now let's shift gears. Scenario B. The Grim Reaper calls. The bus arrives.
You pass away, or you are incapacitated. The primary effect is you stop using the wallet.
I stop signing.
You stop refreshing the connection. You stop moving funds. The silence begins.
And the clock starts ticking.
The clock starts ticking. Let's say you chose a 365-day time lock. 100 days pass, 200 days, 360 days.
My heirs are grieving. They aren't thinking about Bitcoin yet. Or maybe they are, but they can't access it yet.
Exactly. If the evil maid or a burglar tries to use the heir's key on day 360, the network rejects it. Time lock not met. The vault is still sealed.
Then day 366 arrives. What happens?
The magic happens. The protocol conditions flip. The script that governs your Bitcoin recognizes that the time sequence has been satisfied.
The blockchain itself sees it.
Yes. Suddenly, the path that requires your key plus Nunchuck is deprecated, or at least a new path opens up.
And what is that new path?
The new path allows the inheritance key to sign effectively on its own, or in a simplified combination.
So the security wall lowers?
It downgrades, and this is intentional.
Why?
You are moving from maximum security, which is about protecting against theft, to maximum accessibility, which is about ensuring recovery. You are prioritizing the recovery of funds over the absolute security of funds, because the owner is no longer there to protect them.
It's like the bank vault unlocking itself because the manager hasn't shown up for work in a year.
Yes, and notice, Nunchuck, the company, is not involved in this trigger. They don't flip the switch.
Time flips the switch.
Time flips the switch. Even if Nunchuck refuses to co-sign, maybe they are under a government gag order, the heir's key is now powerful enough to move the funds without them.
That's the sovereign part again. You aren't asking Nunchuck for permission.
No.
You are telling the network, I have the key and the time is up.
It's permissionless inheritance. It is a one-way transfer that cannot be vetoed.
I want to pivot to the person on the receiving end of this, the heir. Because I can imagine a listener thinking, this is great for me, the nerd, but my wife thinks Bitcoin is magic internet money.
Yeah, a very common situation.
How is she going to handle a multisig time-locked script?
This is the biggest friction point. You cannot expect your heir to become a cryptographer overnight.
Not a chance.
The guide is very specific about what the heir actually needs to physically possess. It boils down to 3 components.
Okay, lay them out for me.
First, they need the magic phrase.
Magic phrase. Is that technical terminology? Is that in VIP 39?
Last. In the context of Nunchuck's recovery flow, yes. Technically, this represents the wallet descriptor, or the configuration file.
Oh, what?
See, a multisig wallet isn't just a key, it's a map.
Explain that. That's a good analogy.
Well, if you have a single sig wallet, you just plug in the 12 words and the money appears. Easy.
Right.
But with multisig, the software needs to know. Who are the other signers? What is the derivation path? Is it a 2 of 3 or a 3 of 5? What are the public keys of the other participants?
All the rules of the vault.
All the rules. The descriptor tells the wallet how to construct the vault. Without this map, the key is useless.
Right. It's like having the key to a safety deposit box, but not knowing which bank or which city the box is in. The magic phrase or the configuration file is the map.
Exactly. So item 1, the map, magic phrase. Item 2, the inheritance key. This is the actual authorization tool. This is usually a hardware wallet, like a tap signer, cold card, or ledger. Or it's the seed phrase written on steel. This is the thing that signs the transaction.
The map and the key. Got it.
And item 3, which is optional but highly recommended in the guide, the trustee.
Wait. I thought we were getting rid of third parties. Why are we bringing a trustee back in?
We're getting rid of custodial third parties.
Ah, okay.
A trustee in this model isn't someone who holds the money. They don't have the power to spend. They are a holder of information.
Ah, interesting. So like a backup plan for the backup plan, a social backup.
Think of it like splitting the knowledge. You might feel uncomfortable leaving the magic phrase, the map, and the inheritance key, the key, in the same envelope in your desk drawer.
I would, yeah.
If a burglar finds that envelope, they have everything. They can wait for the time lock to expire and steal it.
Right. You've created a honeypot.
So you split them. You give the inheritance key, maybe tap signer card, to your heir. Now, you say, keep this safe, don't lose it. But it's useless to them right now because they don't have the map and the time lock hasn't expired.
And you give the map to the trustee.
Exactly. You give the magic phrase to your brother or a trusted friend. You say, if anything happens to me, give this to my wife.
I see. So the brother can't steal the money because he only has the map, not the key.
Correct.
The wife can't access the money early or lose it to a burglar because she only has the key, not the map.
Correct. They have to collude to attack you, or they have to cooperate to inherit.
That's clever.
It adds a human layer of checks and balances without giving anyone full custody. It uses social engineering to reinforce the cryptographic engineering.
And again, emphasizing the privacy aspect.
Yeah.
When the heir finally combines these things, there's no ID check.
0. When the time lock expires, the heir inputs the magic phrase into the Nunchuck app or any compatible wallet software, taps the inheritance key, and broadcasts a transaction. The network validates it purely on cryptography. No name, no social security number, no probate court. The funds move to a new wallet under their full control.
That is fairly revolutionary. It turns inheritance into a peer-to-peer transaction.
It unbundles the state from the transfer of property. It makes inheritance a private matter between you, your heir, and the blockchain.
But let's be real, with great power comes great opportunity to screw it up.
Massive opportunity for heir. We're taking the safety rails off.
If I mess up the configuration or if my heir loses the key,
the money is gone forever.
Well,
there is no appeal process. You cannot sue Bitcoin.
So let's talk about the practical security guidance section of the guide. If we are walking this tightrope, we need a safety harness. What does the guide recommend to ensure this actually works?
The first thing they hammer home is storage medium, specifically for the seed phrases.
The 12 or 24 words.
Yes. The guide says, use steel, not paper. Steel.
Why steel? Why not just paper in a Ziploc bag? I mean, paper has worked for centuries for books.
Think about the timeline. Inheritance is a long game. You might set this up today and not die for 40 years.
Good pull.
Paper degrades, moisture gets in, silverfish eat it, ink fades, and God forbid a house fire.
Paper burns at, what, 451 degrees Fahrenheit? A house fire gets way hotter than that.
Exactly, way hotter. If your house burns down, you don't want your wealth to burn with it. Steel plates, where you stamp the words into metal, can survive house fires, floods, and collapsing buildings.
Wow.
It is the only medium that matches the durability of the blockchain itself. You want your backup to be as permanent as the ledger.
And I assume digital storage is a hard no.
Hard no. Never, ever take a picture of your seed phrase. Never type it into a Google Doc. Never save it in a password manager.
Why not a password manager? Those are encrypted.
They are, but if it touches the internet, consider it compromised. There is malware specifically designed to scan your computer's memory, your clipboard, your files for 12-word strings.
That's terrifying.
Stay offline. Physical steel.
Okay, steel plates. Got it. Now, there was one tip in the guide that actually surprised me. It advises against using passphrases.
Ah, yes. The 25th word debate.
Usually, security privacy nerds love passphrases. It's an extra password you memorize that encrypts the seed.
Right.
Even if someone finds your steel plate, they can't access the funds without the word in your head. Why does the inheritance guide say don't do it?
Because of the bus factor.
The whole point of this.
The whole point. If the password is in your head and your head is gone, the funds are gone.
But couldn't I write the password down for my heir on a different steel plate?
You could, but now you've increased the complexity. Think about the user experience for your heir.
Okay.
Your heir finds the steel plate. They rejoice. They think, I found Dad's Bitcoin. They plug the words in, the wallet opens, and it shows zero balance.
Why? Why would it do that?
Because without the passphrase, the wallet generates a completely different set of addresses, empty addresses. It's a valid wallet, but it's not your wallet.
Oh, that's heartbreaking. That's a cruel trick.
They panic. They think you died broke. They think you were lying. They throw the plate away.
Oh my God.
Or they assume they did something wrong and give up. It's a foot gun.
That's a nightmare, a total nightmare scenario.
It happens. The guide argues that for inheritance specifically, simplicity is a virtue. You are designing a system for a person who is grieving, confused, and probably not a technical expert.
Yeah.
Don't give them puzzles, give them keys.
A grieving person is not a good puzzle solver. That resonates. We overestimate how rational people are in those moments.
Exactly. Security for you, while alive, often means complexity. You can handle the 25th word because you use it every month. Security for them after you die relies on simplicity. You have to balance that trade-off.
Okay, that makes a lot of sense. Another practical tip, hardware plus paper. Or steel, rather.
Redundancy, yes. The guide suggests giving the heir a hardware device, like a tap signer, which is just a card you tap on your phone. It's super easy to use.
For the convenience factor.
Yes, but electronics fail.
Capacitors blow, chips degrade, batteries die.
And standards change. Try plugging a 20-year-old perishable into a modern laptop. It's a nightmare. In 30 years, USB-C might be as obsolete as a floppy disk.
So the hardware is for convenience, but the steel is the eternal backup.
Yes. Always provide the raw seed words on steel as the fail-safe. If the fancy card doesn't work, the words can always be imported into whatever wallet software exists in the future. The words are the standard. The hardware is just a temporary tool.
Okay, the final practical tip, and I think this is the one that separates the pros from the amateurs, the fire drill.
The testnet approach to life.
Yes, the guide says, don't just set this up with $1 million and hope it works.
Right. It's amazing how many people do this. They build a complex cryptographic vault, put their entire net worth in it, and never test the recovery process.
It's like packing a parachute and never checking the ripcord.
It's insane. So the guide advises, create a small setup first, put $50 in it.
Okay.
Set a short time lock, maybe 2 days.
2 days, yeah.
Then simulate your death. Don't touch the wallet. Wait for the time lock to expire. Then pretend to be your heir.
Become the user.
Become the user. Take the backup materials you prepared for them, try to restore the wallet, try to sweep the funds.
See where the friction is. See what's confusing.
You will find things. You'll realize, oh, I couldn't read my own handwriting on the steel plate. Or, oh, I didn't realize I needed to pay a transaction fee and the wallet was empty, so I couldn't move the funds.
Or just the software interface was confusing and I didn't know where to click.
Exactly. You want to make those mistakes with $50, not your family's future.
That is just... It's so critical.
And more importantly, if you successfully recover that $50, you gain confidence. You sleep better. You know it works. You aren't hoping. You are verifying.
Trust, but verify your own system.
Yes.
We've covered a massive amount of ground here, from the terror of lost keys to the nuts and bolts of time-locked multisig. It's a lot to digest.
It is.
But as we zoom out, I want to talk about the mindset shift here. This isn't just about avoiding probate fees, is it? This feels bigger.
No, it's philosophical. It's a shift from legal sovereignty to mathematical sovereignty.
Unpack that for me. What's the difference?
For all of human history, inheritance has been a social contract. You die, and the tribe or the king or the state decides to honor your wishes and transfer your land or gold to your son.
It's based on social consensus.
It requires permission and enforcement by the group. It works because we all agree it works.
It's a permission system. The state can also decide not to honor it.
Of course.
They can tax it at 50% or seize it.
Exactly. Bitcoin changes that. We are moving to a system where the transfer is executed by code. It is automatic. It is unstoppable.
Right.
It doesn't care if the laws have changed. It doesn't care if the bank is closed. It just executes.
It's the ultimate expression of property rights. It's property rights that exist outside of the legal system.
And for the owner, that brings a profound psychological relief. If you are constantly worried that the system might confiscate your wealth or block your heirs, you carry a burden.
A constant anxiety.
But if you trust the math and you've tested it, you can actually relax. You can enjoy your life knowing that your legacy is secured by the strongest computer network in the world.
That is a powerful thought. It's peace of mind through cryptography.
It is. It solves the final vulnerability of the sovereign individual.
So I want to leave the listener with a thought to chew on. We're talking about wealth that is managed by code that outlives its creator.
Yep.
We are talking about assets that transfer without human intervention, potentially for generations.
Right. It's a new paradigm.
If we have generation after generation passing down wealth through these encrypted sovereign channels, completely invisible to the state, completely outside the banking system, does this fundamentally change the definition of a family dynasty?
That is the big question. You aren't just passing down money, you are passing down the responsibility of sovereignty.
It's a torch. It's not just a gift.
It is. If you give your heir $10 million in a bank account, the bank manages it, the heir just spends it.
They're a customer.
If you give them $10 million in Bitcoin keys, they have to secure it. They have to understand it. If they lose the keys, the dynasty ends.
So the education is just as important as the code.
More important, the code can handle the transfer, but only you can handle the education.
You have to prepare them.
Are you raising heirs who are capable of wielding sovereign power, or are you giving a loaded weapon to a toddler?
Wow. Are you raising heirs capable of wielding sovereign power? That is the challenge. It forces you to think about parenting as much as programming.
That's the work. The code is the easy part. The human element is the hard part.
Well, on that heavy note, I think we've given everyone enough homework for today. Check your backups. Consider your time locks.
Do a fire drill.
And maybe have that awkward conversation with your family.
It's better than the alternative.
Thanks for diving deep with us. Stay safe out there.
Stay sovereign.